Good day. You should have watched a video about sex determination, and now these are notes about sex-linked traits. So what we're looking at here is we need a definition of a sex-linked trait, and that is a trait controlled by a gene on a sex chromosome. And the result is, and that means X or Y chromosome, and the result is the trait is going to be more common in one sex than the other. We're going to look at recessive alleles found on the X chromosome, and it means those traits are going to be more common in males than females. There are two kinds of traits we will look at. One is hemophilia, and the other is color blindness. Those are both traits that are controlled by recessive alleles or genes on the X chromosome. And it works the same way if we're trying to do Punnett squares for these things. So here we're going to say capital B represents the allele for blood with normal clotting ability. Little b is the allele for hemophilia, and that means the blood does not clot normally. So hemophilia is a real worry because if you get a cut and you don't have a clotting mechanism, potentially you could bleed to death. And the same for internal bleeding, which is bruising. So someone with hemophilia is going to have to be very careful. One way they treat it is they do blood transfusions. So let's look at our possible genotypes and phenotypes. It turns out for females, a female can have two of the alleles for normal clotting, so big B, big B. A female can be heterozygous, have one gene or allele for normal clotting and one gene for hemophilia. Or a female could have two genes for hemophilia. Those are the three possible combinations. So these are all female because they're X and X. Now, then we interpret the B's. Well, normal blood clotting, because it turns out normal blood clotting is dominant over hemophilia. So here it's heterozygous, big B, little b, and again it's normal blood clotting. But this person would be called a carrier, because although they don't have hemophilia, they can pass on the gene for hemophilia. And in order for a female to have hemophilia, she must have both recessive genes. And that means it's very rare. Now males, because they only have one X chromosome, they're either going to have it or they're not. And so in the first case, X capital B Y is normal blood clotting, and X little b means they have hemophilia. And if we compare male and female, well, if the male has the gene, one gene, they have the problem. But if a female has just one gene, they still have normal blood clotting. So that is an advantage for females. So females cannot be a carrier of hemophilia. They either have it or they don't. So now we're going to try some sample crosses. So these are our 5 genotypes that we have to choose from. And we're going to say a carrier female, and this would be a normal male. And we say, what could happen here? Well, we load in our Punnett square. Here's the mom. That's her genotype, X big B, and X little b. Here's our X big B and our Y. So meiosis has happened. These would be what are in the eggs. These are what are in the sperm. And we interpret what's going on. Well, these top two things, this would be a female with normal blood, and this would be a female with normal blood, but that female would also be a carrier. This X big B Y would be a male with normal blood, and this would be a male with hemophilia. And so that's what we're talking about. It's a 25% chance for each of these combinations, and wording of questions becomes interesting. So there's no chance that a female will have hemophilia, but if we had a daughter, there'd be a 50% chance of that daughter having a carrier of the gene. If we're looking at all the combinations, then it's a 1 in 4 chance of having a carrier female. Whereas if we just look at the males, 50% chance of the male being normal for blood and 50% chance of hemophiliac. And you can try other crosses, and I certainly will assign some on worksheets. And that's what it's talking about here. So you can give that a go, try these out, and if you're struggling with those, send me an email so we can take a look at things. So that was sex-linked traits.